Alright, next up in Euclid's Elements, Book 1 is Proposition 4, and this is where we're given two triangles. We're told that they have two sides equal and the angles between those two sides being equal. And from that we're supposed to conclude that the two triangles themselves are equal. And although there's a little bit of ambiguity in the way this is written, more or less the route we're going to go about doing this is just putting two triangles on top of each other, lining up what we know to be equal, and then the rest follows from that. But since staring at two triangles on top of each other just looks like one triangle, we're just going to identify the parts here with one another via red arrows and similar coloring. But first off, I guess we should read this. And it says that if two triangles have two sides equal to two sides respectively and have angles contained by the equal straight lines equal, they will also have base equal to base. The triangle will be equal to the triangle, and the remaining angles will be equal to the remaining angles respectively, namely those which the equal sides subtend. So that's lengthy, and just recaps what I already said. So here we line up the point A with the point D, and then A and B and D and E we are given are equal, and we line those up with one another. And then A and C and D and F we are given are equal, and so we line those up with one another. And having done this, we see that point B lines up with point E, and point C lines up with point F. And so we're to conclude that BC lines up with EF. And so since we have the triangles laying exactly on top of each other, corresponding one-to-one, we then take this from this that the triangles themselves are equal, and so therefore the angles contained in the triangles are equal. And that's pretty much the entire proof.